Hi, welcome to the video solution for EDEXCEL past paper. This is EDEXCEL IAL Unit 6, June 2022. So let's start. Question number 1. A student investigated heating a liquid using the apparatus shown. So this is the apparatus given. The control tab adjusts the rate of flow of steam from the nozzle. The steam heats the liquid in the beaker. The student used a kitchen thermometer. The thermometer scale is shown below. State the resolution of the thermometer in degrees Celsius. So if you watch carefully the diagram is we have given two scale, degree Fahrenheit and degree Celsius. So degree Celsius is a lower scale, so you need to read resolution from this the upper reading here if you see the scale. So the way that you read resolution is you look at the first interval, which is 0 and 10. So the maximum value is 10, and then you divide it by number of intervals. So there are two intervals, the first interval and the second interval, divided by 2. So answer is 5. That means the resolution of this thermometer will be 5 degree Celsius. So that's how you can write your answer. The resolution is 5 degrees Celsius. The student heated the liquid. He started the stopwatch and recorded the temperature of the liquid. He recorded the time at fixed interval of temperature as the temperature increased. Explain why this method was better than starting the stopwatch and recording the temperature at fixed interval of time. So what are they saying? They are saying that we need to record the time for fixed interval of temperature. Why can't we do other way around? Why can't we measure temperature for fixed interval of time? The reason is resolution. So if you see the thermometer, the resolution, as we have already found that, which is 5 degrees Celsius. So if the needle is in between any two numbers, suppose the reading is there, like here, something like this. This is the reading. So it is difficult to read accurate temperature, or in between somewhere, or maybe here or any other place. So we cannot read temperature accurately if the needle is in between two reading or two numbers. So of course it will not be accurate. So it is a good idea that we can fix the temperature interval and we measure the corresponding time. It's all because of the large resolution. The student repeated the investigation with different liquid. He started timing at the same initial temperature. State another control variable that would allow him to compare the specific heat capacities for the two liquid. Because we are comparing specific heat capacities, and if you remember, the specific heat capacity C is equal to amount of heat given, delta E, divided by m delta T. So initial temperature will be same. Already they are saying. Another control variable, you can say that the mass of the liquid must be same, or we should give equal amount of heat, meaning the control valve should be open at the same interval of time. The mass is better to write, so you can say the amount of a liquid must be same, or mass of the two liquids should be same. Question number 2, or part 2. The student plotted the graph of temperature against time for the first liquid as shown. So this is the graph, temperature against time. Sketch on the graph the line for a liquid with greater specific heat capacity. So we need to sketch the graph for second liquid with the with the high specific heat or the large specific heat. So again, the same relation, if you see, C is equal to delta E upon M delta T. Amount of given for both liquid, the opening valve is at the same rate and M mass is same. So specific heat capacity is inversely proportional to the change in temperature, delta T. So, or delta T is inversely proportional to specific heat. So of course, the change in temperature will be smaller if a specific heat capacity is larger. So the graph will start from the same initial temperature, but the change in temperature or increase in temperature will be lower as per this relation. So you can say that there is a line with lower gradient, something like this, and the rate of change in temperature will be decreasing. So that's how you can sketch a line with the lower gradient, and the rate of change of temperature will be decreasing. So you can sketch a line something like that. Part C. Another student performed the investigation using a temperature probe connected to a data logger. Give 2 reasons why this would improve the investigation. A typical question, you are using probe to read the data. So of course probe will have a large number of reading. There is a less reaction time. You can measure time and temperature simultaneously, and then of course large number of data, so accurate graph will be plotted. So these are typical answer you always write. You also can say that yes, probe will have a small resolution, so given more accurate result. This is just additional point I'm giving you because they are saying 2 reasons, so we have already written 2 reasons here in this answer. But sometime they ask question that they can say that the temperature, the main advantage of probe is we can measure time and temperature simultaneously. Write other 2 reasons. So you can write large number of points, and you can say the resolution is more accurate, or resolution is small and give more accurate. So it depend upon question. It's better to write know all possible points. Question number 2. 2 identical pendulums are linked together using a rubber band as shown. So we have some setup, a rubber band which is horizontal, 2 pendulum are attached, stand, stopwatch. One pendulum is set in motion. The amplitude of oscillation of this pendulum decreases. Okay, so oscillation is decreases to 0 as the rubber band transfer energy to the other pendulum, which oscillate with the increasing amplitude. So once you start oscillation, one pendulum with the large, and then this is 0, but this oscillation decreases, the oscillation of the other pendulum starts increasing. That's the resonating system. Now the time taken for the amplitude of one pendulum to change from 0 to a maximum and back to 0 again is P. So P is the time period from 0 to maximum and maximum to 0. It is suggested that the relation between P and vertical distance L between the metal rod and the rubber band is P equal to A L to the power B, where A and B are constant. Okay. Devise a plan to test the validity of this relation using a graphical method. So you need to write a plan. How would you start? How will you what quantity you are going to measure? How will you measure? How will you record the reading? And how do you analyze your obtained data? That's all these points that you need to write. So if you see, this is the setup. The idea is first you need to write how will you start your experiment? So of course, because we know that according to equation P depending upon L. So first we measure L, and then for different values of L we are going to measure P. P is the time period for oscillation from maximum to 0 and 0 to maximum, or vice versa. So first we can say that we are going to make sure that the rubber band remains horizontal. We can use the meter rule. We will measure the length L at both end, so that we are sure that the rubber band is horizontal, and in this way we can measure the length. So once we set up, and once we are sure that the rubber band is horizontal, and we measure the length from both end using the set square, of course, and then we start oscillation of one pendulum. And then first we need to make sure that the pendulum is oscillating in a line. It's not a wavy motion, not just wavy motion left and right. So once we are sure that the pendulums are oscillating in a right way, then we start the stopwatch and we start measuring the time, whether from the first pendulum or from the second pendulum, and we measure the time period P from 0 to maximum and maximum to 0, and then we repeat it for the same given length, and we use the mean value. Then we change the length and take the second set of reading. In that way, for different or various value of length, we can have a set of points. So if you wish, you can draw a table that just so you can have a length L and you have a P. So you have a different length, and then you have a P, and then another length, and you have a P, and then another length, and so you have a set of data. Now what will you do with the set of data? Look at that. This is exponential equation, and if you see this exponential equation, you can rearrange in y equal to mx plus c form. So how will you arrange it? So you can use len p equal len a plus b len L. Clearly you can rearrange len p equal b len L plus len A. So if you plot graph of log P on the y-axis and log L on the x-axis, and if you have a straight line with positive gradient, that means the relation or the given relation is valid. So that's how you can write all these things. In that way you can manipulate the answer in your own words or rephrase the answers. So measure the length, so that making sure that rubber band is horizontal, and set the pendulum in oscillation and measure the time for the oscillation. Repeat the process for same given length, then change the length and collect the data for various length. So plot the graph of len p against len a, and then if the relation is valid, the graph should be a straight line, or you can say if the graph is a straight line, then the relation is valid. A student recorded the motion of pendulum using video camera. Suggest how this improved the measurement of P. So again, a typical question of video camera, that video camera or video of any investigation, the most important advantage is we can pause whenever we need it. We can slow down to observe the motion or to analyze the movement or motion or whatever we are doing. So most common scenario is because we are not sure about the exact position where the pendulum stops or from where its pendulum starts moving. So from naked eye, it's almost impossible to judge the exact position. But from video camera, we can slow down, we can pause, and we can find fixed position or exact position from where the motion starts. So that's how you can write the advantage of using video camera. Question number 3. Atoms of an element emits characteristic spectral lines when they are bombarded with a beam of high energy electrons. The spectral lines can be used to identify the element. The relationship between the atomic number Z and frequency f of the most intense spectral line is given by Z is equal to, or Z is equal to k f to the power n, where k and n are constants. Explain why the graph of log of Z, log, log of Z and log of f would give a straight line. Again, a most typical question. Most of the time they give you exponential equation like this, and they ask you why do we have a straight line, or how can we make sure that this is the linear equation. So we convert this exponential form into log form. So this is 2-mark question. You can at least show 2 steps. So you apply log on both sides. So you write log of Z or Z is equal to log of k into f power n. Remember, the idea is you need to do some step or some mathematics so that this equation, you need to show that this equation can be written as y equal mx plus c. If you are able to show this form, then this is the meaning that the graph is a straight line, because they are saying log, so we apply log on both sides. And now we are going to use, so log of Z equal, we use log property, so log of k plus log of f power n. Further, log of Z equal log of k plus n log of f. And now you can rearrange this equation as log of Z equal n log of f plus log k. So this equation can be compared with y equal mx plus c, where m is the gradient, and this is equal to n, and moreover c is y-intercept, which is log of k. So that's how this is a straight line with positive gradient n. Of course, I solved, or I did a lot of steps. You can skip if your mathematics is good. You can skip 2 or 3 steps. At least write three steps or 2 steps so that you can have a full credit. The table shows the frequency of the most intense spectral lines for a range of element. So table is given, some empty column. Indeed, we need to fill the column to plot the graph. So part 1 is plot the graph of log of Z against log of f. So you can use additional column. So here we need to calculate the log of Z and then log of f. They are saying instruction, you don't need to convert 10 to the power 15 hertz to hertz. You leave in 10 to the power 15 hertz. So you just use your calculator to calculate log of Z, each number of log of Z, each value, and you write in the first column, and log of 0.16, log of 0.69, and you write in the second column. Make sure that you must fill the heading with proper unit. Do not forget, because headings are not given. This is the heading column. This is the heading column. Do not forget to write headings along with the unit if there are. In the first column, because this is atomic number, so there is no unit, but here you have unit hertz, so do not forget that. Now if you use your calculator to figure out log of these number, so basically log of 3, if you calculate log of 3, it will give you around 0.477. So 0. I'm sorry about that, 0.4771 and 1. But the all, if you see the frequency is given in 2 decimal place and z's are given in 2 significant figure like this, so you can round it off to 2 decimal place. It's a good idea. So all numbers will be round off in 2 decimal place. So 0.477 will be 0.48. So you will write here 0.48. This is the column log of z. And then you can calculate log of 6 and log of 14 and so on. Similarly, log of f, which is 0.16. So log of 0.16, the calculator will give you negative 0.7958. Again, you need to round it off with with the same significant figures or decimal place. So 2 decimal place, you can round it off negative 0.80. So here you will write 0.80, and then in the same way you complete the table. So once you do that, you have all these numbers. So this is the heading, and these are the values. These are the numbers or the column, complete log values. Next part, plot the graph of log of z against log of f on the grid opposite. Use additional column for this is the same question. Basically, the new column that we found the values is this. But okay, now before moving on, you need to understand the important points plotting a graph, because this is 6 marks, and these 6 marks are distributed with various steps. So very first step is let's discuss about the graph. So whenever you have a graph and you will be given a table like this, so in the table you would have you label the axis, and don't forget, when you are labeling axis properly, you have to don't forget the unit. This is the most common mistake students generally do. They forget to write the unit. Do not forget the unit if there are. And this is the first step, or first mark. The second mark is you choose the appropriate scale so that you can cover more than 50% region of the given graph. So these are the minimum and maximum value of the one axis. This is the minimum and the maximum values of the second axis. So choose appropriate scale so that you can cover, remember, more than 50%, greater than 50% of the region. 60, 70 doesn't matter. If you draw a small graph or region covered is less than 50%, you will lose 1 mark. Meaning your graph should be covering, as per my graph that I gave you here, so it should be more than half from the bottom or more than half from the top. The shaded region, the yellow region must be covered. If you cover this, it will be acceptable. Or from the left side, this is the more than 50% region, or from the right side, it depends on the values given. So if you cover this region more than 50%, then it will be acceptable. Less than this, you will lose 1 mark. This is another thing. Another important point, please do not plot or do not put the dot, which we call blob, for the point on the graph, meaning you do not do this. This is wrong. unacceptable. Instead, we put cross when you are putting the cross. So you will put a cross for a given point. So this is not acceptable blob. So do not do this. And then another thing, do not forget to draw a best fit line or best line of fit or curve depending upon the data set. What is the best fit line or a curve? Suppose this is the a graph. A best fit line or a curve is a point or a curve which are about which all the points are equally distributed. This is important. So all the points that you have plotted must be equally distributed. Equal number of points will be one side and the other side of a line. So for example, if this is the graph and you have a, this is a straightforward simple graph, and you see all the points are on the line, so you join all the points with the line, and this is the line of best fit. But sometimes plots are scattered. Generally what students do is students join all the points like that, which is unacceptable. This is not a best fit line. Do not just join all the point. Remember, you need to draw a line or a curve so that all the points are equally distributed above and below your line. So instead of joining all the points, if you draw this line, so you say that there are 2 points above the line, but none of them are below the line, so this is not the best fit. If you draw this line, so you have a more point below the line but no point above the line, so points are not equally distributed, so it is also not a best fit line. But you need to visualize a line something like that, approximately all the points are equally distributed. This is called the best fit line. So use this idea. Let's go back to our question. We are going to plot the graph. They are saying that the log of, we need to plot the graph of log of z against log of f. So log of z will be on y-axis and log of f must be on x-axis. So you can use this, but it is a good idea that you can flip. So this is now log of f, which is the first independent value. I do it on x-axis, and this is log of z for y-axis. So for negative 0.8, I will plot 0.48. So first I choose the axis so that I can have appropriate region to be covered. So x-axis and y-axis. Remember, because x values are starting from negative number, negative 0.8. So I'm not going to start my origin from here. Okay. Generally we start from here. That's what do we do? But we have all positive values. But because of the negative value, we need to shift origin slightly right side, because 2 negative numbers I need on the left side of the origin. That's why this y-axis should be shifted towards right, and we do not have any negative y value, so of course the x-axis can be at the bottom. So now that's how you see the origin and the plot and the point. So on the x-axis I took 5 box equal to 0.2, and on the y-axis I took 10 boxes equal to 0.2, or 5 boxes is equal to 0.1. So one small box on the x-axis, remember, one small box on the x-axis is equal to 0.04, because 0.2 divided by 5. One small box on the x-axis, 0.2 divided by 5, so 0.04, and one small box on y-axis is 0.1, 0.2. Okay, so that's how you select your number. Now let's plot the point. So for negative 0.8 we have 0.48. Please make sure that we are not going to plot a blob. Instead we are going to plot cross. So now for each point, for negative 0.8 we have a 0.48, and then 0.2 we have a 0.78, and so on. So these are all the points that we have. After that we need to plot a line of best fit. This is the line of best fit. You can have a slightly slightly different, it's okay, because they will give you range of the values. So that's we completed our 6-mark question here. Now let's talk about determine the value of n. And remember, this n was a gradient, so you need to find gradient of this line. To find the gradient of this line, you need to choose 2 points other than those points that you plotted. So on the best fit line you choose 2 points, and remember, when you choose 2 points, make sure that the 2 points are as far as possible, not close enough. So I am choosing these 2 points so that you can show this triangle, okay, and these 2 are the coordinates of these 2 points. We can use these 2 points to find the gradient. So of course the gradient, you can do your working here. Gradient is equal to y2 minus y1, so 1.7 minus 0.56 divided by x2 minus x1, 1.8 minus 0.6, so plus 0.60 or 0.6. Once you do your calculation, your gradient would be equal to 0.475. So n would be equal to 0.48. This is the value of n from the graph for part 2 for 3 marks. Next part is determine the value of k using your graph. Remember, I have already shown before that log of k is the y-intercept. Y-intercept. So the y-intercept you can find from here. This is the y-intercept, and as per my graph, this y-intercept is 0.85. You can take slightly above 84, so 0.85. So you can say that log of k, which is y-intercept, equal to 0.85. And when you need to find k, you remove the log, and this is log of base 10. When you remove log, the other side goes to power of 10. So k equal to 10 to the power 0.85. And then you can use your calculator to find the value of k, and the value of k that you find is 7.079. 7.079. So you can say this is 7.08. This is the value of k. A scientist named Henry Moseley suggested that z is proportional to f to the power 0.5. Explain whether the graph supports the suggestion. So if you see, we have found value of n, which is equal to 0.48, and k is equal to 7.08, and the relation was given z is equal to k f power n. If you substitute this, so z is equal to 7.08 and f to the power 0.48, and 7.0 is constant, so you can say z is proportional to f to the power 0.48. And now 0.48 can be round off to 0.5. So z is proportional to f 0.5. So yes, you can say that the suggestion, the suggestion support the model. Okay. Question number 4, a student measured a metal nut of the type shown below. The student measured the diameter D of the hole in the center of the metal nut. She made one measurement in centimeters using Vernier caliper and one measurement in millimeters using digital caliper. The photographs show the measurement. So this is a Vernier caliper and this is digital caliper. So explain why digital caliper would be better choice of instrument for this measurement. You should include calculation in your answer. So when you compare two instruments, which one is better? So we always compare percentage uncertainty in both measurement. So the less percentage uncertainty would give us a better reading. So we find the percentage uncertainty in measurement of Vernier caliper and percentage uncertainty in digital caliper. So for Vernier caliper, the percentage uncertainty. So first you need to know how to read the Vernier caliper. So here you see the main scale reading is 0.6. So the main scale is for Vernier caliper is 0.6 plus the Vernier reading, which is the fractional part. And for fractional part, you need to look at the best aligned line on Vernier scale. So this is line number 0, 1, 2, 3, not aligned, 4, and 5. Yeah, this is 6. You see here, the line number 6 is aligned best with the above line. So the Vernier reading is 6. So the overall reading is this 6 is a Vernier line. So the overall reading will be 0.6 plus 6 into least count. And the least count is or least count, or you say the resolution. The resolution is 0.001. So 0.001, not 0.001, sorry, this is 0.01. So the reading on the Vernier scale will be 0.66 centimeter. This is the reading. Now the percentage uncertainty in the Vernier caliper will be the resolution will be not the resolution, the uncertainty will be 0.005 divided by 0.66. And why am I taking 0.005? Because 0.01 centimeter is resolution, but uncertainty or absolute uncertainty will be resolution divided by 2. This is the absolute uncertainty. So 0.01 divided by 2 will give you 0.005 centimeter divided by the reading. In that way you can, and of course, because percentage uncertainty multiply by 100. So the percentage uncertainty in Vernier caliper is 0.757%. You can round it off 0.8%. So this is the 0.8% in the percentage uncertainty of Vernier caliper. Now let's talk about digital caliper. For digital caliper, reading is 6.58 and the resolution is 0.01 resolution, but uncertainty again divided by 2. So the uncertainty for digital caliper 0.005. Remember, uncertainty is resolution divided by 2. So this is uncertainty, so divided by 2, and then reading is 6.58. In that way you can have multiply by 100 also here. So 0 0.075, 0.075, and you can round it off 0.08%. Clearly it is less. So that's why digital caliper is better than the Werner caliper. So you can write this statement: percentage uncertainty of digital caliper is less than the percentage uncertainty of Werner caliper. That's why it is better. The student determined a more accurate value for D. Explain one technique she could have used. Remember, again, a typical question of using measuring instrument, especially Werner caliper, digital caliper, or micrometer screw gauge, to improve the reading or more accurate reading. We do the measurement at different position, different places, or different orientation, and we use mean value in order to avoid or in order to reduce the random error or to get more accurate result. The student recorded the following measurement. This is D. Determine the mean value of D and its uncertainty in millimeter. So mean value of D, you can say D is equal to, you add all values together and divided by their total number 4. So 6.57 plus 6.58 plus 6.54 plus 6.52, and then divided by number of readings, so divided by 4. In that way you can have a D is equal to 6.5525. Of course we need to have a consistent significant figure, so round it off, 6.55 millimeter. This is millimeter, and this is the reading. Now let's talk about the uncertainty. So uncertainty delta D is range divided by 2. So range is 6.58, largest minus the smallest, 6.52. So 6.52 divided by 2. So delta D would be equal to 0.03. This is the uncertainty. So you can say 6.55 plus minus 0.03. The student was given a different size metal nut. She measured the distances shown. She calculated the shaded area A of the metal using the following formula. S is given, D is given, area is given. So S and D are given in millimeter here, area is given in centimeter. Show that uncertainty in A is about 0.01 centimeter. So there are various techniques to find the uncertainty from the formula. For me, the easiest way is to find uncertainty with the help of absolute uncertainty or the fractional uncertainty. So you see the formula here. The formula value of A depend upon two factor, S and D, but not just S and D, S square and D square. So first you need to find absolute uncertainty in delta S square, and then absolute uncertainty in D square, not D, which is already given, D square. And then because in formula they are subtracting each other, so we can add their uncertainty. So then you can add them together. So in order to find uncertainties or absolute uncertainty of S square, which is delta S square, so idea is I'm going to find delta S square, which is equal to, because we have a S square, so delta S square would be equal to twice of delta S upon S. This is fractional uncertainty, and then multiply by s square. Of course, one s you can cancel. That means delta s square would be equal to twice of delta s into s. So you multiply all these three to get your delta s square. So twice of 0.02, which is in millimeter. It is good idea to convert in centimeter, because we need to give uncertainty of a is in centimeter square. So we'll do that. So twice of delta s. Delta s is 0 point times 0.002 times s. S is 1.683. So delta s square would be equal to 6.732 into 10 to the power minus 3 centimeter square. This is the absolute uncertainty in s square. In a similar way, you can do delta d square. So delta d square would be equal to twice of delta d over d into d square, and 1d gets cancelled. So you can have twice of delta d into d, meaning delta d square would be equal to twice of delta d, which is in centimeter, so 0.004 times 0.855 in centimeter. So answer would be equal to 6.84. So 6 point, let me just erase it. Okay, so this is 6.84 into 10 to the power minus 3. So this is delta d square, and this is delta s square. So delta a would be equal to delta s square plus delta d square. Once you add them together, so your answer will be equal to 0.013, which is approximately 0.01. That's what you need to prove. The student measured the mass m and the thickness x of the metal nut. So mass x, thickness and area is given. Determine the density of the metal from which the nut is made. So in order to find the density, mass over volume, so thickness and area is given, we can find volume by multiplying these together. So volume would be equal to A into X, which is you multiply these together. So but don't forget, because this is in millimeter, so you convert into centimeter, then you multiply. So when you multiply 0.792, which is x, times 1.88, and the volume would be equal to 1.49 centimeter cube. 1.49 centimeter cube. So the density would be equal to mass over volume, and mass is 10.3 divided by the volume 1.49. Density is equal to 6.917. Round it off to 3 significant figure. Yeah, 3 SF here, everything. So 6.92 gram per centimeter cube. This is the density. The density of steel ranges from 7.85 to 8.03. Deduce whether the metal nut could be made from the steel. Again, this type of questions are coming nowadays frequently, frequent questions. So we have various technique to deduce our result, but for me the easiest way is to compare percentage uncertainties with the percentage difference. So I'm going to compare the percentage uncertainty of the density that we calculated and the percentage difference of the calculated value with these standard value. So if percentage difference is less than the percentage uncertainty, then yes, we can say that the result is valid, or it can be made from these material. Otherwise, if percentage difference is more than percentage uncertainty, then of course it is not valid or it is not made of. So let's figure out percentage uncertainty of the density. So percentage uncertainty of the density is, or you can say, yeah. So first we find delta rho over rho is equal to delta m over m plus delta v over v. So these are the data given. We have delta m over m, but delta v over v, this is the volume. So now we can do further. So delta m over m plus delta v over v, and delta v over v is the fractional uncertainty in the volume, and this delta v over v can be written as delta x over x plus delta a over a. So we have everything. In this way we can find delta rho over rho, and if you multiply everything by 100, it is percentage uncertainty. So you can do that. Delta m is 0.1 divided by 10.3 plus delta x is 0.03 divided by 7.92 plus delta a over a 0.01 divided by 1.88. So in this way you have delta rho over rho 0.0188, and multiply by 100. If you do times 100, so 0.01, okay, 1.88%. This is percentage uncertainty of density. So percentage uncertainty of density. Now let's talk about percentage difference. So percentage difference is a standard value, and I'm going to take the smallest one first. So 7.58, sorry, it's not 7.58, this is 7.85. 7.85 minus the calculated density. The calculated density on the previous page was, I guess, yes, 6.92. So 6.92 divided by, and I've used absolute value here, percentage difference, and divided by standard value 7.85 times 100. And once you do your calculation, your answer would be equal to, the percentage difference will be 11.8%. So percentage difference is greater than percentage uncertainty of the density. So result, so the nut is not made of, so you can write your comments, the nut is not made from the steel. You don't need to check the percentage difference for the second number. If you wish, you can, but again, this is 8.03, so percentage difference even higher than 11.8. So this calculation is sufficient for this conclusion. So of course the nut is not made of made from this steel. Thank you very much. I hope you understand, and all the best for your exams. See you in the next video. Thank you very much.